Hello everyone, this is the video lecture for College Algebra Math 1414 Section 1.2. We're going to solve for x. Oh, great joy. So I'm just going to jump right into it. There's nothing really new to talk about. 1, 2, 1. I got 7x minus 5 is equal to 30. Solve for x. On my math lab, they say solution set, and they have like a box inside a curly bracket braces thingies. I don't know. Anyways, we just want to solve for x. That's all they're really doing here. So I'm going to add 5 to both sides. Makes it 35. We're going to divide by 7. And so x equals 5. Okay, that was easy. Let's keep going. There's nothing else to talk about on that problem. 13, I got 11 is equal to 3 times x minus 3 minus x minus 6. Make that 6 a little bit better looking. And so we're going to solve for x. I'd say let's simplify it first. We're going to distribute the 3. Let's distribute that minus sign. So we got a 3x minus the 9. And then notice here 2 negatives will make a positive 6. Combined like terms, these are x's and these are what I say numbers, because they're just numbers. 3x minus 1x is 2x. And then I got a negative 9 and a positive 6 makes a negative 3. And now you can see it's much easier. I'm going to add 3 to both sides. So I got 14 is equal to 2x. Divide by 2 on both sides. And that makes 7. Cool. All right. So skipping ahead to number 17. Again, as I'm reminding you again that this is not number 17 on your homework. I don't know if you even have 17 questions on your homework. You might. I can't remember. But this is like number 5 or whatever it is. I don't really know. I want to do the ones in particular that are different, interesting, I would say hard maybe. And so this is one of them. Notice that we have fractions and I need to solve for x. So I get really freaked out here. Fractions, I don't know what to do. You know, how do I combine like terms and stuff? There's a much easier way to do this problem and anything like it. So let me show you. Instead of trying to common denominator everything or something, because I mean, this is just wild. I'm going to take this, I don't know, I'm going to say it here on the video. That's fine. I call it bad math. It's not really bad math, just my notation is. I'm going to multiply everything here by 72. Now, why 72? Well, where'd that come from? Well, notice right here and here, these guys, if I multiply them together, I get a 72. What I'm getting at is if I multiply everything on the bottom and I find like the biggest number on the bottom possible, and if I multiply that by every single term gets the 72 in the top, what should happen is we should get some canceling, okay? Let me show you what this looks like. I got 72x over 8. I got 72x over 9. And then I got 15 times 72. Now, it looks like a lot, but things should cancel right now. Notice that we got 72 over 8. Well, go figure, that's a 9. We got 72 over 9. Oh, wait, I know that one. It's an 8. I mean, it's kind of like they're opposites in a way. They're opposites? I don't really know. 15 times 72, that's a calculator. That's 1080. And now look at this thing. That's so much easier to work with. Minus 8x on both sides. 9 minus 8 is 1. And so I get a negative 1080 as my answer. That's it. That's the entirety of that problem. Now there's going to be other ones like that, so let's keep going. And I'm going to do this bad math style a couple more times to show you. But again, very simple. The concept is simply just taking your denominators, you're going to multiply them together to see what the biggest number could be in the bottom, and then just multiply that by everything in the top. Stuff should cancel. Got 1, 2, 29. I got x plus 3 divided by 2 is equal to 1 minus x plus 1 over 3. And I'm looking at my denominators here, and I'm thinking, well, what would be the biggest number that would cancel at least something from every fraction? And it's 6. I'm going to multiply everything by 6. You can see right here, 2 and 3. You multiply them, you make a 6. Now, you could, if they have like some kind of common factors between these two numbers, you can make it a smaller number sometimes. But I just say multiply them. It makes it much easier. I'll show you as we keep going as well. So multiply everything by 6. So I get a 6th in the top for every term. I'm not even trying to do math right now. I'll do the math here in a minute. For now, I'm just saying we'll write a 6 everywhere. Well, 6 over 2 is a 3. 1 times 6 is 6. And 6 over 3 makes a 2. Distribute your 3. Distribute your, I would say, negative 2. So 3x plus 9 is equal to 6 minus 2x. Notice now negative 2. Combine like terms, I'm going to add 2x to both sides. Sounds like a good idea. Let's minus 9 on both sides. And so I got 5x is equal to, and on this side I got 6 minus 2 minus 9. So what did I get on my paper? I know, right? Negative 5. There we go. That sounds about right. So divide by 5 on both sides. X equals negative 1. There you go. So not too bad. Again, the main idea is to, let's get rid of these fractions. I mean, do you like fractions? I don't like fractions. Nobody likes fractions. So let's get rid of the fractions as soon as possible. And then it's easy math. Same thing here. I got 4 over x is equal to 8 over 5x plus 4. I'm looking for something that would multiply by everything to cancel out what you can. And I'm going to show you this time, I'm going to say 5x. Okay, now you could have also said 5x squared. You would still get the same answer as me. But I just feel like I'm going to go a little bit easier this way. It's not as many x's, I guess. So I'm going to distribute this 5x. Again, what's going to happen, I'm kind of already knowing that I multiply these together, but at the same time, you don't need 2 of those x's because when I distribute 4 times the 5x over x, 8 times the 5x over 5x, and then 4 times 5x. Everything gets a 5x. Well, here the x's are going to cancel, making a 20. Here the 5x's are going to cancel to make an 8. And then here we just got 20x. See, that was easy. Again, you could have done it the other way. You would have gone down another road, I suppose. I prefer making it as simple as possible. And I think it's fairly obvious that a 5x would cancel both of those terms. Okay. Divide by the 20, and I got x is equal to 3/5. All right, awesome. So I put that into my math lab, and wrong. Wait, why? Hold on. That's not the math. This math is great. My math lab's kind of weird here. Part A is asking for when is the denominator going to equal 0? When is the bottom equal to 0? This is part A. I didn't read very well, let's just say. I just wanted to do the math. So when is the denominator of this original right here? When is the denominator ever equal to 0? Well, when is the bottom ever equal to 0? You can see these guys right here would be equal to 0. That's x equals 0 and 5x equals 0. The only time that this would happen is when x equals 0. It's just right there. So if you're trying to say, well, solve for x or something, it's not really anything else to do. It's kind of already done. So 0 is the answer. So for part A, you're going to put x equals 0. And then part B, they want to solve and all that kind of stuff. And that's when we put in, actually it has little curlies here, the 3/5. Okay. So just watch out. You know, they try to put things, little roadblocks in front of you. They're going to do this again here in a second. It's not hard. Just watch out. Okay. 1, 2, 47. So I got 3 over x plus 15 minus 4 times x minus 15 is equal to 4x over x squared minus 225. So what would cancel everything here? I wouldn't go down that road here, honestly, because it gets a little bit more complicated. I'm seeing that this and this right here, if you multiply them, you get this guy. When you FOIL them, yeah, I think you FOIL them. FOIL factor, I can't remember. So regardless, we're going to combine these two together somehow. I want a common denominator. Common denominator. And if I get that, then it should look really good on both sides, essentially. In order to do that, I'm going to take this x minus 15 and multiply it here, top and bottom. And I'm going to take this right here, this x plus 15, and multiply it top and bottom. I'm hoping that you've seen this before. I don't want to have to go through these steps every single time. But the point is, you know, this is what we're doing, and we'll go faster as we get further in the class. Okay, so that's my common denominator. I don't really have to do the math. I already kind of see the 15s are going to cancel in the middle. 15 times 15 is 225. These are the same thing. So I'll go ahead and write it, just so that I can say that I did it. Yep, you can say that I had done this whole problem, even after I explained it. Whew, lots of writing. Okay, oops. Okay, cool. They got the same denominator. I don't want to say common denominator here. It's not like that. I'm just saying that this thing is equal to this thing, and they have the same denominator. So I can basically just ignore the denominator for right now. I'm really just concerned about getting these numerators to look the same. In a way, I got 1 over 2 is equal to x over 2. Well, I mean, I don't really care about the 2's. Solve for x. You see what I'm saying. That's the idea that we're doing here. Distribute the 3, distribute your negative 4. And so I got 3x minus 45. I got a negative 4x minus 15 times 4 is 60. Should probably grab my calculator. Combine like terms. These guys combine. You know what? See that 4x over there? I'm going to add 4x to both sides. Then I'm going to minus 3x on both sides. So negative 45 minus the 60 is equal to, that's 8 minus 3 is a 5x. Combine these like terms. What is that, 105? Divide by the 5. I got negative 21. Cool. Again, part A, they're saying find the denominator equal to 0. And so it looks just like this on my math lab. If you go back to the very first original up here, and I'm using a different color, I'm looking for when these bottoms are equal to 0. All bottoms, any bottoms. Since they're going to be the same in the end, like we had just done, I can just solve for x on these two individually. It'll make it a little bit easier. You don't have to solve that side, but if you can, or if you want to, you can. You'll just get the same answers. Switch your sign, negative 15, positive 15. And so that's my answers here. And then they have the little curlies. You put your 21 inside, and we're good. Okay. Next one. 1, 2, 55. I got y sub 1, that's a little 1 down there, subscript, is equal to 3 over x plus 5. I got a y sub 2 is equal to 4 over x plus 3. And then they got a y3, which is equal to 11x plus 9, all divided by x squared plus 8x plus 15. They also state with all this that y sub 1 plus y sub 2 is equal to y sub 3. And that's your key statement right there that you're looking for. When you first see this problem on my math lab, it'll look confusing. I mean, like, what am I supposed to do? It's all these things going all over the place. I'm confused. I don't know what's going on. Don't, no, 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 no. It's not that bad. They're just saying this guy plus that guy equals that guy. That's really all they're saying. And what it ends up being is basically the same problem we just did a second ago. It's not any harder than what we just saw a second ago on the last problem. There, this is your real problem. That's all it is. And from here you solve for x and da 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 da. So it's not too bad. Notice that this is actually an easier problem because the 5 and the 3 will make that 15, and I'll also make the 8 identical to the last problem. Identical to the last problem. So I'm actually not going to do it. I know, that sounds so sad, doesn't it? Not because of time's sake or anything, but I can't do everything for you. I could do a lot of them, and I set it up. Now you understand, when it looks crazy, it's not that crazy. It's just like the last problem. Moving on. 1.261. So I got 2x plus 10 is equal to 5 times x plus 2 in parentheses minus 3x. Now, this one's weird. I mean, it looks easy, right? Why am I doing this one? Distribute the 5. I'll show you what I'm meaning here. Combine like terms. Let's just pause for a second right here. I got 2x plus 10 equals 2x plus 10. True. Notice that they're like the same thing. I don't know. A equals A. I mean, it's like, yes, good job. You're not doing anything new there. I could kind of even go further. I don't really have to. Let's just say I'm minus 2x on both sides. So that goes away. Let's say I'm minus 10 on both sides. Now watch out. 10 minus 10 is 0. 10 minus 10 is 0. Is 0 equal to 0? Yes! So what do I put? What's the answer? Like, solve for x? No, there's no solve for x. There's nothing else to do. This is what you're going to put. Okay? That's why we're doing it here. In the curlies, you got an option to do x such that, vertical lines mean such that, x is a real number. My handwriting's really poor. You're going to definitely start reading it a lot better as we keep going. Okay. X is a real number. X such that x is a real number. What does that even mean? It means all numbers work. All numbers work. That's what they're trying to say in English. And then they're going to ask, this is your answer, and then they're going to have some other kind of thing you have to do, and you would say, yes, it's an identity. Identity. That's your other answer. Identity. Again, that just means all numbers work. Another word that I would say for identity is like formula. Formula is pretty close to that. This is a true formula. I don't know where you'd ever use it. I know I don't. But, I mean, it's just in the class. We're talking about it. Let's do another one. 2 times x plus 4 is equal to 6 plus 2x. Same thing. Solve for x. I got 2x plus 8 is equal to 6 plus 2x. Now, right here, this is kind of looking a little weird. I'm going to keep going, okay? Because they're not identical, so I'm just going to keep going. Identical, identity, okay. Just thought of that. Wow. So 2x minus on both sides, they actually cancel. I'm left with 8 is equal to 6. Huh? 8 doesn't equal 6. 1, 2, 3, 4, 5, 8. No. False. False. I don't know. Something's going wrong. Wrong. Bad. This is true bad math. So how do I say that in my math lab language? Well, that's what you're going to put. You're going to click the solution set is null. Null. null set is really what it is, but null or nothing. Nothing is another way to say that. There is no answers. No numbers work. I mean, because every time you're going to result in something that's just false. So that's your answer, and then you're going to also have to do inconsistent. That sounds like there's a problem, doesn't it? So I know those are kind of weird. They're like, just two strange questions moving on. You're like, whatever. What was that for? It's just there. That's why we're talking about it. I don't want to leave you hanging. But at the same time, they're not really hard. It just ends up being multiple choice. So this one here, 97, is a word problem. And a lot of times word problems scare us. And so what I do is I try to break it down to the formula. I just want to see, like, what's the formula? What are they asking for? What's going on here? So I got this p plus x over 2 equals 37. They say p is a percentage. Well, that makes sense. And then x is years after 1970. They also have a little chart here with some boxes and stuff, and they got 2010 right here, and they got a 19%. Okay. So it says use the model to find a percentage in 2010. Use the model to find percentage in 2010. Well, I mean, so x is years after 2000, or I'm sorry, after 1970. So I got 1970. And I'm going to 2010. How much x do we have here? We should have 40x. And so x is equal to 40. I'm going to plug that in, solve for p. That's it. When it says model, by the way, this keyword model, what they're meaning is formula. They're wanting to say formula. I don't know why they say formula. They should say formula. Anyways, so I got 40 over 2. Got a 37 here. So 40 over 2 is 20. Minus 20 on both sides. I got 17. That's your answer. It's 17%. P is a percentage. And that's actually your part A answer. Part B, it says compare with the graph. Are we overestimating, underestimating, that kind of thing, which you've seen before. Well, ours is under. Ours is underestimating. So that's like you're going to click under. And then by how much? Well, so then 19 minus the 17 is 2%. Now, you want to make sure that this is positive. Keep it a positive number because you said that it was underestimating. That kind of implies that we're getting a negative result, right? 17 minus 19 is a negative 2. So you don't need to include the negative sign twice or something. We understand that it's a negative, and then you just say, well, give me the number. The number would be a 2. The number. Okay, part C. It says, now, let's reanalyze this problem here. Now we got P is equal to 2. What year are we talking about? So my percentage is 2%. Solve for x. And so I got my P plus x over 2 is equal to 37. And so then 2 plus x over 2 is equal to 37. I'm going to minus 2 both sides. 35. I'm going to multiply by 2 over here. And so what you get is x is equal to 70 years. Now, this is kind of interesting. I'd say, 70, done. Well, no. They're years after 1970. So 1970, I'm going to add 70 to that. So I should get 2040. On my paper, I actually just did it like this. Oops, it's a 70 we're adding to make it this guy here. So that's another way. 2040 is what they're really wanting out of that. And I got one last question here. 103. So I got P is equal to 0.7x minus 0.8. then all divided by 0.7x plus 0.1. Okay. There's this chart on the side here. It's it's some kind of a, I don't know, line, the dashed one. I honestly cannot remember what they're talking about. I just have a picture like this on my notes, so I might as well show you. And I think that's a good thing that I don't always remember what these problems are, because I don't want to like do it for you. I want to do it with you. And so like this is the basics of what's going on. We got a formula. This is what the graph looks like. They say in the problem that my p percentage is 82%. Solve for x. That's it. I don't actually have the work for this. As in, like, I just didn't do it. And that's okay. So, again, I'm going to skip this problem, kinda. But what I want to do is, because it looks intimidating, I want to just set this thing up and just show you what it would look like. Okay, so I got the 0.82. So you go to 0.7x minus the 0.8. And then I got the 0.7x plus the 0.1. Well, what should my first step be? Get rid of that fraction. I'm going to multiply that whole thing, that whole denominator, over here to this other side. So times the 0.82. And we got this stuff over here. Just because they're decimals doesn't mean they're hard. Just because you see fractions doesn't mean it's hard. Look, there's no more fractions, and decimals are just calculator stuff, right? Next step would be to distribute that 82 to both of these guys. Combine like terms. Look, you got your x's, you got your numbers. It's really pretty basic after that. So I set it up for you. Now you know what to do. And that's all I got in this section. So we're done. If you have any questions, you just let me know. Thank you very much. Have a great day.